Hi, and welcome to our the first episode of our series on factorization. So before we go into factorization, let's just kind of understand what a factor is. And by now you should know that factors are numbers that can divide into other numbers without any remainders. So if I looked at the number 6, the factors would be 2 and 3, obviously 1 and 6 as well. So these are the factors. So if I'm doing factorization, it's going to be kind of taking these factors out, these pairs, because I know 2 times 3 is 6 and 1 times 6 would be 6. It's kind of working with those pairs of factors that multiply into another number. It looks a bit weird if I do something like this. If I asked you what are the factors for 2 and x, you'll be like, okay, well, that's a bit weird. I know for 2 it would be 2 and 1. But the factors for 2 and x are actually 2 and x. Because x can go into 2x and 2 can go into 2. 2 times x will give me 2x. The same as here. 2 can go into 6 and 3 can go into 6 and 2 times 3 would go into 6. So it is a bit strange to see it like this, but let's just look at an example. Now before I look at an example, factorization is basically just the opposite of expanding brackets. So if we had something like 2 is x plus 5, we'd usually get this and we want you to expand these brackets and we'd say, okay, 2 times x is 2x and 2 times 5 is 10, and then this would be what we want to get at. But with factorization, it's going the opposite way, and I want to go from here to here. So let's just take a look at what that looks like. Let's say we start off with 2x plus 10, and they ask us to factorize. So what I have to do is the first question in factorization is always how many terms are there? Because I would say the goal of factorization is always to get one term. We won't always get one term, but that would be the goal. We always kind of shoot for the stars and hope we get there, but we don't always get there. But in this case, we will. So my question is there something that can go into 2x that can also go into 10? Now, usually we look at the numbers on their own. So question is there a number that can divide into 2 without a remainder that can always also divide into 10 without a remainder? And yes, the answer is 2. So I write a 2. Now, there's not an x common in these two factors, so I can just write a bracket, and then I ask myself a question. 2 times what will give me 2x? Well, 2 times x. And I can put the plus there. And then the next question, 2 times what will give me 10? Well, that would be 5. So now I factorized. I just went the other way. And I can always test it because 2 times x is 2x, so that's correct. And 2 times 5 is 10. So we're going to do a couple of examples, but it does get tricky, so make sure you understand the basics. Let's start with a couple of questions. Let's do 4x plus 6, and we'll do 3x squared plus 2x, and yeah, let's just start with those. So in the first one, I ask you to factorize this. I have to ask myself one question: how many terms are there? So, well, before I get to the terms, I can't add these two things, right? Because they're not like terms. So then I'm going to opt for factorization to get them kind of into a smaller one term, if possible. So I look at 4 and I look at 6. Is there anything that can divide into a 4 and a 6? Yes, a 2. So I write a 2. And the next thing, x, there's only x on this side, there's not an x on that side, so I'm going to open my next bracket. And my question is, 2 times what will give me 4? And that would be 2. And I have to add the x, because 2 times 2x will give me 4x. And then I can add this, just bring down the plus. And the next question is 2 times what will give me 6? And that would be 3. So I factorize this because now this is one term. I know there's like 2 terms in between, like in the brackets, but this as a term, this would be seen as one term. Very important, I have to make sure that on the inside here there are no common factors. So between the 2 and the 3, there's nothing, and the x there's nothing. So this would be correct. If I multiplied these two, I would get there. And if I multiplied those two, I would get there. So factorization. Cool. Let's look at the next example. So here the 3 and the 2, they're not factors. There's nothing common, no common factors between 3 and 2. But there is an x squared here and an x there. So it means that there's an x that's common. So I can take out an x, but only one x, because there's one x here and two x's being multiplied here, but I can only take one x out because it has to be common for both. Now my next question is, what is x times, well, x times what will give me 3x squared? Well, 3x, because I know 3x times x will give me 3x squared. I just bring down the plus, and then x times what will give me 2x? That's 2. So I factorized, because this is one term, and I know x times 3x will be 3x squared, and x times 2 would be 2x. I'm going to do a couple of more examples, see if we can make them a little bit more tricky, but I think for the first step, this is perfect. Let's do 7xy plus 14xy squared. And let's do something like 4x plus 6x. Okay. For this one, to factorize, I can look at the numbers first. Is there anything common between 7 and 14? Or is there a number that can go into 7 and into 14 without a remainder? And that answer is 7. Then next I look at the x. There are x on both sides, so I can take out an x as well. And then the y, there's a y common on both as well, so I can actually take a y out, but only one, because there's only one here, and there's 2 there. And then I can open my next bracket. Now the question is 7xy. I took the whole term, so what should I fill in here? I should still fill in a 1, because 7xy has to be multiplied by 1. A big mistake is just to kind of leave it out and just go directly in there and write the 2, because you know 7 times 2 would give you 14. But that would be a very, very big mistake. We're going to throw away a term. So we have to remember this magic 1 and add the plus. And now I can ask the next question. For the next term, what do I have to multiply this by to get that? So we start off with a 2. So 7 times 2 will give me 14. The x, I don't have to multiply because it's already there. The y, there's one y there, so I have to multiply with another y. So this is one term. Is there anything common in here? No, there's not. If I multiply this and this, will I get that? Yes, absolutely. And if I multiply this and that, would I get this? Let's just check. 7 times 2 is 14. X would be there, and y times y is it. So that would be fine. So that's factorization. In this one, we can factorize, but there's a little trick. Maybe you spotted the trick already or the little mistake, but let's factorize it anyway, and then we'll see if we really need it to factorize. Is there anything common in here? Yes, there's a 2 that's common, and an x. And 2 times 2 would give me 4. And then I add the plus, and that would be a 3, because 2 times 3 would give me 6. And yeah, the x is already there. But now it's like 2 times 3. I have something, I can actually add these things together. So 2x would be 5. And now I can think I factorized. But I didn't really factorize. I didn't have to factorize here. It's a bit of a trick question. I'm really sorry. But these are like terms, so we could have just added them together to get 10x. So it's important that you don't always blindly just look at like, oh, let's factorize or whatever. Kind of just ask, are they like terms? In this term, we did factorize, yes, and we got this 5. And if I multiply this in here, I would get this. But I didn't really have to do all of this, although it's not wrong. It was just not necessary. Okay, in the next video, we're going to look at a bit more, let's say, a bit more advanced examples.